Hello everyone, welcome to Augment Tech. In this session, we will be learning about Python matplotlib, scatter plots, and bar plots. By the end of this session, you should be able to understand how to create scatter plots, how to compare the plots, the colors, color each dot, color map and color bar, the size, alpha, scatter bars, horizontal bars, bar color, width, and height. I'm excited to get started and hope the same from you. Let's get started with creating scatter plots. So with pyplot, you can use the scatter function to draw a scatter plot. The scatter function plots one dot for each observation. It needs two arrays of the same length, one for the values of x-axis and for the value on y-axis. So here the point this corresponds to both x and y will be plotted onto the scatter plot. So here we first import matplotlib.pyplot as plt and then numpy is np because here we'll be creating two arrays x and y. So the length of both arrays x and y should be same and the points, let's say the point on x-axis that corresponds to point on y-axis will be plotted onto the graph or plotted onto the plot. So there we go. For the first point, 5 and 99, it falls somewhere here. This is 99 on y and this is 5 on x-axis. Now let's say the observation in this example is of 13 cars passing by. The x-axis shows how old the car is and the y-axis shows the speed of the car when it passes by. Now let's figure out, is there any relationship between the observations? So it seems that the newer the car, the faster it drives. Now let's see how to compare the plots. So in the previous example plot, there seems to be a relationship between speed of the car and age of the car, like how fast the car passes by and how old the car is. But what if we plot the observation from another day as well? Will the scatter plot tell us something else? Let's have a look. So here we have again imported matplotlib.pyplot as plt and numpy as np, and then we created two arrays, and then the same observation we have taken for another day as well. So there we go. This is how the comparison plot looks like. So here you can see in the scatter plot we have dots of different colors. For the first set of x and y arrays, the scatter plot is showing the blue dots, and this for second set of x and y arrays, the scatter plot shows orange colors. So if you notice here, the first point 5 on x-axis and 99 on y-axis is somewhere here, and for the second set of array, 2 on x-axis and 100 on y-axis falls somewhere here, this one. So this is how you can compare the plots where the scatter plot shows the dots in different colors. Now let's see what are colors. So you can set your own color for each scatter plot with a color or the C argument. So here, while plotting the scatter plot, we can actually specify the color argument. This color could be any color, as it supports 140 colors, or it could be a hexadecimal color value, or you can also make use of shorter version of colors. So there we go. Here I changed the color of one of the observation to hot pink, and the other observation is kind of green color that is represented in hexadecimal value. Now let's see how to color each dot. So you can even set a specific color for each dot by using an array of colors as the value for C argument. So for each of the value, we can specify colors. So for example, if we have 10 values, we need to specify 10 different colors. So the values will be corresponding to that particular color that we have passed. So here we again plot scatter plot passing x and y points and then the value for colors. And there we go. This is how the output looks like. So here you see each of the point is different in color because here again we created another array holding different colors. So each of the point will be colored with that particular color that we have passed. For example, x on 5, 5 on x-axis and 99 on y-axis is red in color. So the dot that corresponds to 5 on x-axis and 99 on y-axis is red in color. Similarly, you can check for other points as well. Now let's have a look at the color map. So the Matplotlib module has number of available color maps. A color map is like a list of colors where each color has a value that ranges from 0 to 100. So there are different color maps available, one of which is Veridis. So there we go. These are the color combinations that are under this C map Veridis. Likewise, we also have different color maps available that we can use to color our dots on the scatter plot. Now let's see what is the color bar. So you can include the color map in the drawing, including the plt dot color bar statement or function. So there we go. Once we uh, plot the scatter plot by passing x and y values, the value for colors in CMap, then we can say plt.colorbar. So what happens here is this actually creates a color bar at the right hand side, which is actually the combination of the uh, colors of the dot that we have plotted on the scatter plot. So you can see here the different colors in the color bar are same as that of the colors that we have in our scatter plot. If you mention some other C map here, the color combination of dots would be actually coming from the same C map that shows up here in the color bar. Now let's see what size is. So you can change the size of the dots with S argument. So here you can um, specify how small or how large the dot of the scatter plot could be. Just like colors, make sure the array for sizes has same length as the array for x and y axis for each dot taking a specific size. And there we go. Here you see I created an array of sizes, and let's say we have 10 observations, or let's say in this case we have 13 observations for each x and y. It means that in order to specify the size for each of the dots, we need to have an array of size that is again holding 13 values or 13 observations. And then we can pass that array to our S argument that stands for sizes. And there we go. This is how the output looks like. So the higher the value, the more bigger the dot looks. The lesser the value, the smaller the dots. So this is about the size. Now let's understand what alpha is. So you can adjust the transparency of the dots with the alpha argument. So alpha here is going to make the color of the dot transparent, or it is going to show us how opaque or how transparent the color of the dot can be. Just like colors, make sure again the array of sizes has same length as that of the arrays for x and y axis. So when we say alpha is 1, it would be the darkest color. When we say alpha is 0.5, it will be transparent, like it becomes transparent. And when we specify the value of alpha to be 0, it becomes completely transparent. So it means your dot should not be visible when you specify value of alpha to be 0. So this is how alpha shows us how transparent or opaque the dot color could be. Now let's see how to combine color, size and alpha. So we can combine a color map with different sizes of the dots. This is best visualized if the dots are transparent. So there we go. Here we import Matplotlib and NumPy, and then we create 2 points x and y, and then colors, sizes, and then we pass colors, sizes, value for alpha and the C map. In this case, C map is nippy spectral, and then we also specify the color bar, and there we go. This is how the output looks like. So here we get a nice visualization of a scatter plot. Now let's see what are bar plots or how to create the bars. So with pyplot, you can use the bar function to draw bar graphs. So here, let's say we import matplotlib.pyplot as PLT and import numpy as NP, and then we create two arrays. Let's say X is having values A, B, C, D, and Y is having values 3, 8, 1, 10. And then when we do bar plt.bar and then we pass X and Y, there we go. This is how the output looks like. So our X is A, B, C, D, and our Y is the values 3, 8, 1, 10. So you can see A is 3 somewhere here, B is 8, this one, and C is 1 falls somewhere here, and D is 10. So this is how we can create bar plots using plt.bar, and we can pass the values for x and y or the x and y access to our plt.bar. Now let's see what is this bar function. So the bar function takes arguments that describes the layout of the bars, the categories and the values represented by first and second arguments as arrays. So again we have here x-axis and y-axis. So the points on x-axis denotes male and female, and the points on y-axis denotes numerical values like 400 and 350. So when we do plt.bar, there we go. This is how the output looks like. So you can see we have male, 400 males and 350 females. Now let's see what are horizontal bars. So if you want the bars to be displayed horizontally instead of vertically, we can use the bar H. Here H stands for horizontal. So this bar H function, to this bar H function, we can actually pass our points X and Y. There we go. This is how the output looks like. So you can see this is actually the Y axis and this is actually the X axis. So you can see A is 3, A is 3, and then B is 8, B is 8, C is 1, and then D is 10. So this is how the horizontal bar graph looks like. Now let's see what is bar color. So the bar H and the bar function takes the keyword argument color to set the color of the bars. Like in scatter plot, each dot were represented with different colors. We can also represent our bars with different colors or one specified color. So in this case, let's say the color of the bar specified is red, and there we go. You see, all bars are colored with red. Now let's understand bar width, that is how much width the bar takes. So the bar takes the keyword argument width to set the width of the bars. So when I say width equals 0.1, you see the bars are very narrow and very small in width. So higher the value of width, more broader the bars look, and lesser the value of width, more narrower the bar looks. So this is how you can set the width of the bar. Now let's talk about the bar height. So the bar H takes the keyword argument height to set the height of the bars. So there we go. Lesser the value of height, lesser the bar height, and also this could be only done on the uh, horizontal bar plot. Now let's hop to Jupyter Notebook and check out the example of matplotlib, scatterplot, and bar plot. I'll see you there. Now here I'm on my Jupyter notebook. Under the Matplotlib folder, I'm going to create a new Python notebook and let's name this as scatter plots. The first plot that we are going to discuss here is scatter plots, and then we'll go for the bar plot. So I'm going to specify the title of my notebook as scatter plots, and then let's specify the heading as scatter plots. Let's have a markdown here that says the scatter function plots one dot for each observation. And it needs two arrays of same length. So here we'll see an example of very simple scatter plot. So let me first import the required libraries. So here I say import matplotlib.pyplot as plt, and then import numpy as np, and then x and y array. So here I say np dot array. Let's say we have 6 observations, 5, 7, 8, 7, 2, and then 9, and then y equals np dot array. Let's say 99, 86, 87, 92, 90. So here we need to make sure that the two arrays are of same length, that is holding same number of elements. So in both of my x and y arrays, I have 6 elements. And then now I can go into plt.scatter, to which I can pass my x and y points. And then I can simply go and run. So here I got an array error. Let's check what error it is. So it says x and y must be of same length. So this is 3, 3, 6. All right, I need to have one more value here. Let's say 94, and let's go and check now. And there we go. This is how the output looks like. So you can see 5 on x-axis and y on 99 on y-axis is somewhere here, this one, and then 7 on x-axis and 86 on y. So there we go, it is here. 7 on x-axis and 86 on y-axis is this point. All right. So here we have values for x-axis and then corresponding values on y-axis for each of the dots. So here, let's say this observation shows the result of 3 cars passing by, where x is the age of the car, like how old the car is, and y says how speed the car could be driven. So if we figure out the relationship between the observations, we can say that the newer the car, the faster it drives. Now, what if I have to compare the plots? So here I'll specify a markdown saying compare the plots. So in order to compare the plots, we will be taking the other day into consideration. For example, here I say again x equals np dot array, and then y equals np dot array. This is for the day 1, where I can have values like 5, 7, 8, 2, 7, 9, and then 99, 86, 87, 90, 92, and let's say 94. And another set of array x and y. This is for the day 2. So let's say here we have 4, 6, 7, 9, 10, and then 8. Y equals np dot array. Let's say it is 96, 87, 85, 93, 99, and then 100. So here for my first day, I can say plt dot scatter x comma y, and then again plt dot scatter x comma y. There we go. Let's go and check the output. And there you go. This is how the output looks like. So here we have dots that are blue in color and dots that are orange in color. Okay, let's figure out which one is blue and which one is orange by looking at the points. So if we see this first point, 5 on x-axis and 99 on y-axis. So if you see here, 5 on x-axis and 99 on y-axis is the blue point. So it means for the first day, we have the dots. For the first day observation, we have the dots blue in color. And if you look at the second day observation, the dots are orange in color. So if you see here, 4 and 96, 4 on x-axis and y on 96 on y-axis is this point. So that is orange in color. So this is how we can compare the dots on each day for the observations. So here the two plots are plotted with different colors. By default blue and orange, but we'll also go and see how to change the color of these dots in a while. Now let's see how to set the color. So here I'm gonna have a markdown saying color. So here I say you can set your own color for each scatter plot with color or C argument. So here, let me create two arrays, x and y, let's say 5, 7, 8, 6, 9, holding 5 values or 5 observations. Another array, y, let's say this is 99, 100, 85, 90, 92. And then I can say plt dot scatter, to which I can pass x and y. And I want to set the color to it something like hot pink. And let's say I have another set of observations for x and y points. Let's say they are 6, 5, 7, 8, 9. And then y equals np dot array. Let's say it is 100, 98, 92, 85, 87. And then plt dot scatter x comma y. Let's say this time I'm going to specify the color value as hexadecimal code. So let's say I want these points to be green in color, so I could do something like 00 double F double 0. Let's go and check, and there we go. You see, this is how the output looks like. So the points corresponding to the first set of arrays is hot pink, and the points corresponding to, or the dots corresponding to, the second set of arrays is green in color. So here I've used the hexadecimal value for the color green. Now if we want, we can also go and color each dot with different color. Let's see how to do that. Again, here I say x equals np dot array. Let me have 5 values again. Let's say 6, 7, 8, 9, and 10. Y equals np dot array. Let's say it is something like 80, 99, 85, 92, and 95. And then I do plt dot scatter, to which I can pass x and y. Alright, so what am I supposed to do here is, for each of these points, I want the dots to be colored with different colors. So what I'll do is, I'll also create another array of colors. Let's say np dot array. Here I'm going to pass a list of colors. Let's say red, cyan, beige, hot pink, purple, and then green. So I can now pass C equals colors. So C is the argument that we use to specify the colors, to which I'm passing the list of colors. So let's go and see. Oh, this gives me an error. Let's go and check what error it is. It says C argument has 6. Okay, let me take out any one of this. Let me take out this green. We need to make sure that the colors are also of same length as that of x and y. And there we go. This is how the output looks like. So here we have dots of different colors: red, cyan, beige, hot pink, and purple. So this is how we can color each of the dots. Now let's see what is ColorMap. So Matplotlib module or library has a number of available color maps. So we will be discussing about those color maps now. A color map is nothing but a list of colors where each color has a value that ranges from 0 to 100. So if we talk about the Veridis color map, it ranges from color purple, that is at 0, and then goes to yellow, which is at 100. So here I'm going to create the x and y array, let's say holding 10 observations each. Here I say something like 5, 7, 8, 9, 6, 4, 5, 8, 10. So this is, I need to have one more here. Let me say it is 3. And then y equals np dot array. Let's say 99, 90, and 80, 85, 87, 98, and then 92, 89, 100, and then let's say 93. And I'm gonna again have a list of colors, np dot array. So this is not the list of actual value for the color, but it is the values that are ranging in our color map. Let's say it is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So here we have 11 observations. Let me write one more here, and then we'll do plt dot scatter, to which will be passing x comma y, and then c equals colors comma c map equals, there it is. Let's go and check. And this is how the output looks like. So you see each of the dots are actually the combination of this, where it is color map, where for the value closer to 100, it's purple. There we go, you see it's purple. And then the value that goes up is actually yellow. Now let's understand this by using a color bar. So this should be a markdown. Let me change this to a markdown. And then here, let's say I want to use the same points over here. And then I'm going to do colors equals 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And then I'm going to do plt dot scatter x comma y comma colors, or c equals colors, and then I can pass the c map. This is where it is, and then I can do plt dot color bar, and there we go. This is how the output looks like. So as you see, for the 0 it is the purple color. As it goes up, you can see we have yellow color at value 100. So there we go. This is how the output looks like. So we have so many other color maps available. We have color maps for blues, for greens. Let's check the same with blues and see how the output looks like. So when I say blues, and there we go. You see, here we have the color map of blue and the color uh, bar showing the values. For light blue it is 0, and as it goes up to 100 it is the dark blue. Similarly, you can check for greens as well. There we go. This is how the output looks like. So we have different color maps available. You can use any one of it. Now let's see how we can specify the size for each of the dots. So here I'm gonna change this to markdown, size of dots, and then let's say x equals np dot array. Here I'm gonna take some 5 observations. Y equals np dot array, and then let's say 100, 85, 95, 90, 92, and then an array for sizes. Let's say sizes equals np dot array. Let's say the sizes are 20, 50, 500, 800, and then 10. And then I can do plt dot scatter x comma y. To the s argument I can actually pass my array sizes. And then now when I go and run, it should show me default blue colored dots with the specified values for sizes. Alright, so this is how the output looks like. More the value, bigger the size. So you can see for 500, 800 we have bigger dots, but for smaller values like uh 10, I have the smallest available dot, that is on 10 on x and y on 92. So if you go and check here, this is 10 on x and y on 92 is the smallest dot. So these dot sizes are actually corresponding to the values on x and y that we have passed to this array. Now let's see what is alpha. So this argument specifies how transparent or how opaque the color is. So you can set the alpha value. So here I'm going to again say x equals np dot array, to which I'll be passing 5 observations. Let's say 5, 6, 7, 8, 9 and 10. Corresponding points of y, let's say np dot array. Let's say it is 90, 100, 80, 95, 85, and then sizes equals np dot array. Let's say the sizes are something like 20, 30, 100, 500 and 800. And then I can do plt dot scatter, to which I can pass x, y, s equals sizes, and then alpha equals, let's say, 0.5. So the color, the default color blue should be now uh, half transparent. Let's see, this gives me an error. Okay, it says x and y should be of same size. I might have, okay, let me remove this. We just need 5 observations, and there we go. This is how the output looks like. So if you compare this with the previous plot, you see here the dots are dark in color, but if you see here, these are way lighter in color because I have specified the value of alpha to be 0.5. If I again decrease the value of alpha to 0.2, you must be seeing more transparent or lighter dots than before. If I say the alpha value is 0.0, it should be completely transparent. We have the points because the alpha value is 0, those have become transparent. And only if I set alpha value to 0.1, they should be the dark dots, same as the above example where we didn't specify the alpha value. So let's keep the alpha value 0.5 here. Alright, so this was about the alpha. Now let's see how to combine color, size and alpha. Let's change this to markdown. So here I'm going to first import matplotlib dot pyplot as plt, and then let's import numpy as np, and then let's say x equals np dot random dot randint 100 comma size equals 100, and then let's specify the array y np dot random dot randint, and then 100 comma, let's say the size is again 100, and then let's say colors equals np dot random dot randint, let's specify 100, and then size equals 100, and let's say sizes equals 10 times np dot random dot randint 100 comma size equals 100, and then here I can say plt dot scatter x comma y, c equals colors, s equals sizes, and then c map equals, let's say this is nippy spectral, and then the value of alpha 0.5, so the color would be transparent. Let's go and check the output. So this actually gives me error. Let's see. Okay, it says S must be scalar or float. Alright, let's go and check. Alright, because I have specified size here, let's specify sizes and go and check. There we go. This is how the output looks like. And to this, I can also go and add the color bar by doing plt dot color bar. Hit enter. There we go. This is how the output looks like. Then you combine the color, size, and alpha arguments of the scatter plot. Now this was about the scatter plot. Let's go and see bar plot. So I'm gonna go back to my matplotlib folder. I'm gonna create a new Python notebook here. Let's name this as bar plots. Let's name this as bar plots and a heading here as bar plots. And then let's see how to create the bar plots. So here I'm gonna again say a heading as creating bars and a markdown here that says with by plot. We can use bar function to plot or to draw bar graphs. Now let's have a look at the example. So for this, we first import required libraries like matplotlib.pyplot as plt and then import numpy as np and then let's say x equals np dot array of a comma b comma c and comma d. So these are the points on my x-axis and y equals np dot array 3, 8, 1 and 10. And then here I'm gonna do plt dot bar of x comma y and there we go. Let's see, this is how the output looks like. So for point A on x-axis, that should be a corresponding point 3 on y-axis. So you see A on x-axis is 3 on y-axis, B on x-axis is 8 on y-axis, C on x-axis is 1 on y-axis, you can see here, and then D on x-axis corresponds to 10 on y-axis. So here the bar function takes the arguments that describes the layout of the bars. The categories and their values represented by the first and second argument as arrays. Example, if I say x equals male and females and the corresponding value on y is something like 400 and 350 and then I can do plt dot bar of x comma y and there we go. This is how the output looks like. So we have 400 males and 350 females. Now let's see what are horizontal bars. So here I write a markdown saying horizontal bars. So here we can display bars horizontally instead of vertically. Using bar h function. So here I can do something like x equals np dot array and then let's say the points are a, b, c and d y equals np dot array. Let's say it is 3, 8, 1, and 10. And then I'm gonna do plt dot bar h, to which I'm gonna pass x and y. So here I need to close the bracket, and there we go. This is how the output looks like. So you can see this is a horizontal bar graph where this is our y-axis and this is our x-axis, and the bars are actually plotted horizontally by using bar h function. We can also specify the color of the bar. So here I say bar color. So both our bar and bar h function takes a keyword argument to set the color. For example, if I say x equals np dot array and then a comma b comma c and d, y equals np dot array, let's say 2, 7, 1, 10, and then here I do plt dot bar, to which I'm gonna pass x comma y and then color argument. Let's say the color I want is green, so I'm gonna specify the color as green, and there we go. This is how my bars are displayed green in color. I can also specify hexadecimal value for green here, that is 00FF00, and there we go. This is the green color that we got by specifying the hexadecimal value for color. Similarly, I can also create uh, or specify the color for my horizontal bars. So by doing x equals np dot array, and again I pass the points, let's say a b c and d, and then y equals np dot array, let's say 2, 1, 7, and 10, plt dot bar h, to which I can pass x, y, and let's say the color is red this time. And there we go. This is my horizontal bar graph with red color bars. So you can specify any color you want here, like some rare colors as a hot pink. You can either specify the color name or the hexadecimal value for color. So here it supports the colors, 140 colors, or you can either specify the hexadecimal value for the colors. Now let's see bar width. How to set the bar width? So here I say the bar function takes the keyword argument width to set the width of bar. So this should be a markdown. I'm going to change this to markdown, and then let's specify the x and y points here. Let me specify n x equals np dot array. Let's say abcd are the points on my x-axis, and y equals np dot array, and then it's 2, 7, 1, and 10. And then I'm going to do plt dot bar. Let's say this is x comma y comma width equals, let's say I'm going to give 0.1 as the width. Let's go and check. There we go. You see here the bars are very narrow because I've specified the width to be 0.1. So if I specify higher value for the width, let's say 2, and you see this is how my bars look like. They are too much broader. If I specify 1, see this is my bars with width 1. So I'm gonna change this to again 0.5, and this is how my output looks like. So the default width value for the bars is zero point 0.8. So if I only go and say zero point 0.8, this should be my default width value. All right, like we got above. This is the zero point 0.8. Now let's see how to specify the height. Let's say this is bar height, and so the bar edge takes keyword argument height to set the height of bars. Let's change this to markdown. 06 equals np dot array, and then let me get the points from above, this one, and let me copy it here. And then let's say I have to do plt dot bar edge, and let's change this to code. So because we have edge here, it means it's gonna be a horizontal bar graph. So here is x, y, comma, height. I'm gonna specify like 0.1, and then let's go and check. So this is how the output looks like. If I only specify larger value here, let's say 0.8, and you see this is how the output looks like. So it is actually increasing the height like this. So this actually becomes width when you're talking about bar a height. This is height. If I only say 1, should be seeing the height is increased more. Again, the default height is 0.8. So this is the height. All right. So this was all about matplotlib scatter plots and matplotlib bar plots. So in scatter plots, we have seen how to create the scatter plots, how to compare the plots, how to color the dots, how to color each dot with different colors, the alpha value, the color map, and the color bar. In bar plots, we have seen how to create uh, a bar, that is vertical bar, horizontal bar, how to specify the color for the bars, how to set the height and width of the bars. That's all for this session. Hope you enjoyed the session. We'll see you in the next.